Hurricane Milton, an unprecedented storm. The meteorological world has been shaken by an unprecedented phenomenon, Hurricane Milton. This Category 5 tropical cyclone has left an indelible mark on the history of natural disasters, defying predictions and breaking records in its wake. Milton initially formed as a tropical depression in the warm waters of the eastern Atlantic, about 620 miles west of the Cape Verde Islands. Within days, exceptionally favorable atmospheric and oceanic conditions led to its rapid intensification, turning it into a Category 5 hurricane on the Saffir-Simpson scale. Its unusual trajectory, deviating from typical Atlantic hurricane routes, has kept meteorologists and authorities on edge. Milton initially headed northwest, threatening the Lesser Antilles, then abruptly turned north, skirting the U.S. coast, before heading towards Europe. This unpredictable path has challenged existing forecast models and highlighted the need for more advanced prediction systems. What makes Milton truly extraordinary are its unprecedented features. It maintained sustained winds of over 174 miles per hour for a record 72 consecutive hours, showcasing an intensity rarely seen in Atlantic hurricanes. Its diameter of hurricane-force winds reached a staggering 620 miles, making it one of the largest hurricanes ever recorded. The storm's massive size contributed to its far-reaching impacts, affecting areas well beyond its direct path. Milton also broke records in terms of atmospheric pressure, recording a minimum pressure of 872 millibars, the lowest ever measured in an Atlantic cyclone. This extreme low pressure contributed to the storm's ferocity and longevity. Speaking of longevity, Milton remained a Category 5 hurricane for over a week, another record in meteorological annals. This extended period of peak intensity has baffled scientists and raised questions about the potential effects of climate change on hurricane behavior. Adding to its list of unique characteristics, Milton developed a rare, perfectly symmetrical double eye wall, a feature that fascinated meteorologists worldwide. This structure, while visually striking, also contributed to the hurricane's destructive power and stability. The passage of Hurricane Milton has left a trail of destruction and highlighted the vulnerability of coastal infrastructure to extreme weather events. Economic losses are estimated in the hundreds of billions of dollars, severely affecting sectors such as tourism, agriculture, and maritime transport. Coastal cities faced unprecedented storm surges, leading to extensive flooding and damage to buildings and infrastructure. The long-term economic impact of Milton is expected to be felt for years to come, with some affected areas facing lengthy rebuilding processes. Paradoxically, Milton has also brought unexpected benefits. Torrential rains have alleviated drought conditions in some regions, replenishing water reservoirs and bringing relief to parched landscapes. Additionally, the global attention focused on this phenomenon has boosted investments in climate research and early warning systems. Governments and organizations worldwide have pledged increased funding for meteorological studies and disaster preparedness initiatives. Hurricane Milton has been a stark reminder of nature's relentless force and the urgent need to address climate change. Scientists warn that while Milton is an extreme event, it could be a harbinger of what's to come in a future marked by global warming. The storm's unprecedented characteristics have prompted researchers to re-evaluate their understanding of tropical cyclone formation and intensification. This phenomenon has catalyzed discussions on several critical issues. There's a renewed focus on improving weather prediction models to better forecast the behavior of such extreme storms. The need for strengthening coastal infrastructure has become apparent, with engineers and urban planners reassessing building codes and city designs in vulnerable areas. Climate change adaptation policies are being prioritized in many countries, with a particular emphasis on protecting coastal communities. Furthermore, Milton has underscored the need for closer international cooperation in disaster management, as the storm's impacts crossed multiple national boundaries. Beyond the statistics and meteorological data, Milton has profoundly impacted millions of lives. Stories of resilience, community solidarity, and heroic rescue efforts have emerged, showcasing humanity's capacity to unite in the face of adversity. These personal narratives add a powerful emotional dimension to the scientific analysis of the storm. From families who weathered the storm together to first responders who risked their lives to save others, the human stories emerging from Hurricane Milton are both heart-wrenching and inspiring. As the world recovers and reflects on this historic event, one thing is clear: Milton has marked a turning point in our relationship with extreme weather phenomena. The question that lingers is, are we prepared for what might come next? The lessons learned from Hurricane Milton will undoubtedly shape our approach to climate resilience and disaster preparedness for years to come. The legacy of Hurricane Milton extends far beyond its immediate impacts. It has not only rewritten meteorological record books but has also redefined our understanding of tropical cyclones. Its influence will be felt in policymaking, scientific research, and public awareness of natural disasters and climate change for generations. The storm has served as a wake-up call, highlighting the urgent need for global action on climate change and disaster preparedness. As we face an uncertain climatic future, the story of Milton serves as both a warning and a call to action for governments, scientists, and citizens alike. It reminds us of the power of nature and the importance of respecting and understanding our environment. The world will be watching closely to see how the lessons from Milton are applied and whether they will lead to meaningful changes in how we approach extreme weather events and climate change as a whole.